Welcome to Co-working and Circuits with Flux. I'm super excited about having our guests Torrey and Dan today. We're going to talk about pill robots. We're going to give you some updates on Flux, and we have a little surprise at the end of the live demo. It's going to be super fun. So yeah, this is an event, if you haven't been here before, that we host every month with other makers, entrepreneurs, designers, electrical engineers, all sorts of awesome people who are creating awesome things. And that's what this event is about. So if you're on our newsletter, it's probably how you heard about it. If you're not, sign up. You can go to flux.ai and get on the list. So, and also FYI, we're recording this so that we can share it with people who weren't able to attend, because that's a common ask. So yeah, also want to introduce Matthias. So, I'm Lance, by the way. I'm a co-founder of Flux, and we have Matthias here as well, who's the CEO, and he's going to give some updates on a little bit kind of high level in case you don't know much about Flux, kind of what we're up to and what we're excited about, kind of what's coming next. So I'll give it to you, Matthias.
Yeah, thanks, Lance. Hi, everyone. I'm Matthias. Like Lance said, a co-founder here and CEO at Flux. I'm really excited to have all of you. This is, I think, our fourth event, and these are super fun. I'm especially excited today here for Torrey and Dan and the team to join us today and talk about their work and give us a demo. About Flux, I think most of you guys know what we're doing. We got fed up with the existing tooling for electrical engineers. We want to build like a modern platform, that incorporates like modern, workflows, allows for fast iteration cycles. And for all of you interested, I'm going to drop a link here in the chat. We just started our private beta like 3 or 4 weeks ago. So sign up and we get you going there. Passing it over back to Lance here.
Yeah, definitely. And just if you have projects that you're working on that you're really excited to try a new platform with and you're comfortable sharing, feel free to reach out to Matthias or I. So it's Lance at flux.ai or Matthias at flux.ai, and tell us about what you're working on, because we want to know. Cool. So now I'm super excited to introduce Torrey. So Torrey and I met from the Burning Man Makers Facebook group, and
That's right.
kind of chatted back and forth. And I didn't realize that I'd actually known about your amazing Tesla coil builds with your Burning Man camp. So it's kind of legendary in that whole community. So super stoked to meet the creator, and I guess your whole team, actually built that first, which you can get into in a little bit. So, and by the way, for all the participants, if you have any comments, questions, anything like that, feel free to use the Zoom chat, and we'll be kind of fielding those questions and relaying them as we go along. So, Torrey, yeah, you build giant Tesla coils. You're also the founder of Indiotics, and you're a 14-year startup and medical device designer, the founder of a Burning Man theme camp known as Sextant. And with Indiotics, your team is seeking to usher in a new age of micro robotics inside the human body. So I think my first question to you is, how do you go from giant Tesla coils to building pill robots?
Well, I think the most important thing is, when we say founder, with Indiotics, I've actually never claimed the title of like founder. I've only ever been co-founder, right? And that's been awesome, because it took me many years to realize that you could actually ask for help and go meet people that had different skill sets than you do, and not feel like you have to do everything. So with Indiotics, we basically have 3 nearly equal co-founders. And we came out of the Sextant experience basically really dusty and really hungry to do the same kind of crazy stuff we did in the desert in Silicon Valley. We founded Sextant when we discovered Burning Man. We wanted to participate. We were quite blown away at the scale of the artwork and the stuff going on out there. And so we basically said, hey, what's the craziest, most dangerous, hazardous things we can put together from an engineering science background? And that turned into like big towers with zip lines. And then our co-founder Dan, who's CTO of Endiotics now, came to us and he's like, hey, I want to build a big Tesla coil. And we're like, how big? And he's like, I don't know, 5 feet tall. And we're like, all right, let's do it. And that's when the human ego got involved. And slowly we just started like turning the knob as far as we could go. And what I love about Burning Man is it provides you this clean, empty slate to just go ballistic. And so we were able to really get ambitious, really, really ambitious, kind of for the first times in our lives in certain ways. And so basically, after getting our asses kicked for 3 straight years with the Tesla coil, we finally got it working. And then we started asking ourselves, like, what can we do in Silicon Valley that brings that same kind of passion? And we've all seen science fiction. We've all seen, we've all imagined about nanotechnology, like little nano robots fixing your cancer or healing you. And, but when you actually get sick and you actually go get the standard of care, there's nothing like that, right? And so Endiotics really is just trying to take the first step towards that future we all envision, which is, let's get an autonomous like robot that can actually go around and do things inside the human body, maybe use it as a platform to do other stuff too.
Yeah, it kind of reminds me of Miss Frizzle, Magic School Bus, reminiscent of that, just going like inside, flying around cells and things like that.
That's exactly right. I mean, we're trying to create the Magic School Bus for the human body, and like basically our tech is basically just saying like, what's the simplest way we could actually move around? And we started to realize, what if we made a robotic submarine that could swim the way a quadcopter flies? Because you can get really elegant motion out of a drone, for example. And so we basically use 4 little cell phone vibrator motors driving 4 little propellers. And this quad pump jet is our way to not only move around, but also get really elegant control. And so the goal is just to give a doctor an Xbox controller instead of, shoving a tube into the human body.
Yeah. Yeah, I'm wondering, do you want to, I think so Burning Man is the way that a lot of like founders get together. I mean, Matthias and I, Chris, we all met at Burning Man and we're just kind of linked up through this, creative energy and just like wanting to create something very ambitious. I wonder if, do you want to play that video of the Tesla coils first, and then we can dive into the pill robot? Is that cool?
Yeah, let's do it. So this is like a minute and a half, and it just kind of shows you the scale of the Tesla coil project and what Sextant was all about and is all about.
Cool. I'm going to play it. Let me know if you can't hear it.
Hey. Come on, let's go. Yeah! Let's go! All right, okay. All right. And I'm eating at the beat like it gave a little speed to a great white shark on shark. We raw, time to go off, gone. Deuces goodbye, I got a world to see. And my girl, she wanna see Rome. Caesar make you a believer. Nah, I never ever did it for a throne. That validation comes from giving it back to the people. Now sing this song and it goes like, raise those hands, this is our party. We came here to live life like nobody was watching. I got my city right behind me. If I fall, they got me. Learn from that failure, gain humility, and then we keep marching.
Can we go back? This is the moment, tonight is the night. We'll fight till it's over, so we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us. Go back, this is the moment, tonight is the night. We'll fight till it's over, so we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us.
So that's a really fun little story there. And, you know, the people walking around in stop motion in that video are PhDs, chemical engineers, people from the Google Moonshot Factory. You meet interesting people in places like Burning Man, and the opportunities for collaboration are pretty amazing. That was 2016, and that was our third burn in a row bringing the Tesla coil. And the funny thing was, we blew the circuits during build week, and we literally thought we were going to do the third burn without sparks, right? And you know, when you tell your community you're going to build a giant thing, and you do it, and you can't do it the first year, but you bring it anyways, and you bring it back the second year better, but still not working. Third year, not working. You know, you get a lot of voices saying, hey, maybe you guys should just give up. And what I love about the Sextant family and the Burning Man community is it's a place, I guess, kind of like co-working circuits right here, where the makers and the collaborators can just lay themselves bare, raw, open, and honest, and you just bring what you have and you do your best. So we realized we weren't going to be able to make sparks that year because we had blown up all the circuitry, but Dan, who's on this call, who designed this Tesla coil, ended up realizing, hey, I've got spare parts back in Redwood City. And so they walked him out to the Burning Man airport with an Israeli startup founder who now has come onto the cap table as one of our investors. And these two guys got a free ride from the Burning Man airport in the desert all the way to, I think it was Palo Alto. And they hopped in a lift, spent 18 hours soldering up a new board, and hitchhiked back to the burn with a family member. And by Wednesday of that burn, we made, 16, 18-foot lightning bolts. And yeah, the Tesla coil's cool. It's neat to hear it. It's cool that you can play a piano and you can put music through it. We've even done like human voice, high fidelity type sounds. But more than anything, it was an opportunity to get really ambitious and really ask a lot more of yourself than you might have in the past. So seeing Dan design custom electronics and circuit boards for this thing was a lot of fun. It was also fun when he'd say, see this part of the circuit, that needs to be in like 1/8 inch copper plate, and that component's going to weigh 300 pounds. And basically marrying the worlds of the mechanical, the electronic, and sort of digital and analog together is really fun. And I think sticking to this project really set us up to be able to go do Endiotics.
I have a question for you. I mean, this is of course a very exciting project. Like for Dan, I have a question. Like, what was like the most maybe like surprising thing you learned along the project?
Yeah. So the Tesla coil was, anybody who's been to Burning Man knows, like getting something working, at your house where you can just drive over to the hardware store, in 5 minutes is very different from the environment out there, because you got like wind and dust battering you, and if you find out you don't have something you need, it's like that's at a minimum. It's like hours of drive back to Reno, and in our case, that year, we had to like beg an airplane ride back, right? From the sort of multi-year experience, I think we all really learned, how to sort of plan for things to go wrong and have, multiple backup contingency plans for that sort of stuff. So that was obviously a big learning experience.
Yeah. But one of the things that we took from that, sorry to cut in like that, but Burning Man was canceled this year due to COVID, but a few people went out to over Labor Day weekend to the playa, and just kind of tried to distance, but soak up a little bit of that. We had the opportunity to head out and actually take our robots, and we were able to deploy and operate our robots inside my stomach out on playa this year. And it was really, it was spiritually kind of awesome to sort of connect that moment in time to just a few years before that, when, we said, guys, we need to go back to Silicon Valley. Like, we've made enough lightning for now. But to actually deploy the robots and have them functional on playa meant a lot to me, at least. Yeah.
Yeah, I feel like there's this difference between the projects that you do at Well, they're intrinsically motivated. You know, you're kind of just so excited about it, you just will it into existence, and Burning Man's kind of a platform for that. And then you find other people who are intrinsically motivated by building awesome things. So I guess the lesson is, if you're looking for co-founders and whatnot, Burning Man is a great place. You know, if you can survive on the sand, you know, you can survive in the venture capital world.
Yeah, the whole bottom row of our advisory board is high-level Burning Man builders, artists, makers, and just like biohackers extraordinaires. People do really interesting things when you remove a lot of the physical constraints and you give them a platform and a bunch of support.
Yeah, exactly. So I'm wondering, so we can talk about the transition from Tesla coils to pill robots. What got you, had you always been into kind of biotech or medical? I guess you were in product and for medical products for, you know, a little over a decade.
It convoluted path, starting in being born into a dirt floor cabin. I was weighed in produce later that day, and you know, raised by hang gliding hippies. But those hippies loved science fiction and air shows and stuff. So it was an eclectic background. So I kind of wanted to build, like, you know, the world's greatest, like, one person sport jet, right? So I went off to become an aerospace engineer. But along the way, I just really loved making stuff. And so I kind of slaughtered my academic performance by taking lots of unnecessary manufacturing classes. But I just needed to educate myself in that particular way. And as soon as I got out of college, the second time, I was able to somehow find my way into the startup community here in the Bay Area. And so it was a med device startup. And I didn't know anything about med device or really that much about anatomy, besides like really enjoying physiology back in high school. But they were making objects in really small teams, working late hours, and the family aspect of a startup company where people truly care about each other just totally took me over. And my whole career has now been in small medical device startups.
And then, you know, the problem that you're solving is it initially going after like colonoscopies, or what kinds of
so our problem solution is really simple. The problem is that there aren't tiny robots inside everyone, and the solution is endiotics. And that, I say that with a little tongue in cheek, because it's always been just dead obvious to me that we need microscopic robotic surgeons inside the body. Like, to me, that just seems obvious, and it pisses me off that we don't have that right now, much like jetpacks, anti-gravity flying cars, and faster than light travel, right? Like, these are obvious things that we need. And so if you want to do a real problem solution thing, actually there's some great opportunities here. So if I want to have a look inside your body, I have to jam a scope down you, probably sedate you. That scope's not going to reach everywhere. And so there's some barriers to entry. Whereas we're saying, if you want to have a look inside the human body, dude, skip lunch, drink some water, swallow this pill, and let's go have a look. It's kind of like a much lower barrier to entry. And we think on average we're going to have this robot in people about 3 doctor's visits earlier than they might get scoped. And we just see it as an opportunity to be like a lot cheaper, a lot less intrusive. And then when we start putting surgical tools on it, that's when things start getting kind of crazy sci-fi cool. And we do want to take these to like rice grain size, using like wireless power and obviously, you know, custom ASICs, and do like brain surgery from this platform. But in commercial terms, there's a $40 billion market annually for devices that go in the GI the GI tract, which is basically endoscopes, colonoscopes. And so we think that bringing active diagnostic power, you know, grab your Xbox controller, drive this around. This is Mario Kart in your guts.
I love that you have a game controller for it.
You know what? Like, I could give you a giant rolling cart with like 80s style on it, but honestly, a lot of doctors out there grew up playing video games, and no one's really pushing back on that. So we very much mean to, you know, hold the human lives in our trust with great respect. But there's a huge opportunity cost when you stop innovating. And so, the first time someone swallowed a pill camera, which just passively moves through your body, that was in 1997. So like we're 23 years into the concept of swallowing electronic pills.
Wow.
Dude, let's make these things move, and then let's use it as a platform to do things. I mean, that seems obvious to me.
Yeah.
How are you
I'm
guiding
curious.
it through the GI tract?
Yeah, that's a great question. So, and thank you for the question. Like, we're gonna try to just bring in live
Yeah,
questions.
let 'em
If
rip,
we need
let 'em
to,
rip.
we'll moderate. But
Sorry to interrupt, Lance.
No worries, that's great.
This is the reason why we're doing this, is to actually have a conversational thing. I don't want to just talk at you. So this is a quadcopter submarine. It's got 4 pump jets, and you can differentially thrust those 4 pump jets forward, backward. And so with our joystick, and you basically get a pretty elegant kind of motion that you can do. We say that this swims the way a quadcopter flies. Maybe the second half of your question is, how the hell does that work? Well, I haven't eaten anything all day, and you may notice I'm drinking a lot of water. I'm turning my stomach into an artificially suitable environment for this kind of robot. Can I get another glass, by the way?
Well, I imagine it would be water plus laxative, right? You'd have to do the same sort of prep you do for a colonoscopy.
If we were going to go down and do colonoscopies, which we've done to ourselves, then you drink a bunch of polyethylene glycol. It's horrible stuff, and you flush your whole system out. But for an upper endoscopy, to look in the stomach, skip a meal and drink some water. Seems to work really well for us. And so we're hoping that a lot of patients have their experience of, like, I went in on a lunch break, drank some water, I swallowed this weird pill, played a cool video game with my doctor, kept my street clothes on, didn't get sedated, drugs, anything, and just went back to work. So we're hoping to kind of change the experience of endoscopy, at least for our first product.
Which makes it a lot more accessible, so you don't have to be sedated. You can just, maybe the cost of sedation going to a clinic and
sure,
that whole.
We're big fans of the X Prize Foundation. I mean, I literally saw Spaceship One when it claimed the X Prize, and I had some friends, that had worked on that. One almost died in one of the explosions. So X Prize and space exploration and just like bleeding edge tech is I feel like a kindred spirit to that. And for us, we just feel like we really need to try to disrupt in a positive way. So Peter Diamandis of X Prize says, if you want to disrupt, you got to do it 10 times better and 10 times cheaper. And so we're starting to examine, like, right now our cost of goods, I think we're about $35 to build it. I think we could probably get around $25 pretty soon. Pill cameras sell for about $500, so you sort of have a 95% gross margin baked in. Mm-hmm. We're starting to ask the question, if you can take this pill sooner than an endoscope, like first visit instead of third visit, that saves a ton of money. And then if we need to sell this cheaper to do it, I think we would explore that option, because honestly, Peter Diamandis is chest thumping and challenging founders to disrupt. And so right now we're running on the numbers. How do we make this 10 times cheaper than endoscopy? How do we make it 10 times better? And I hope we achieve or exceed the goal, but if we only get halfway there, we're there because we're getting challenged by people like Peter.
Yeah, I think it's definitely a moonshot to get all the electronics, mechanics, the physics, kind of start changing as you get smaller and smaller. Maybe you could talk a bit.
We call it a pillbot shot, actually.
Pillbot shot. Love it.
Throw in a shot glass, put it back.
I have a photo of the, like each prototype up, the kind of water bottle down to the next version, down to the next version. I'm surprised at many different things. I'm surprised at the speed that you were able to solve some of these kind of mechanical challenges, because I know like the problems that you solve at a larger scale become different. I wonder if you could maybe talk a little bit about just kind of the mechanical or electrical problems that you had to solve to get it smaller, and then maybe even from where you're at right now, like how do you get smaller and smaller? Is it going to be nanobots at some point?
Well, let's go on a quick little drive through history. So we started, we finished Burning Man 2018, and we all agreed as a team, like, okay, enough. We need to skip 2019 as Sextant and go to Silicon Valley. Like we've done enough learning at Burning Man. Now let's find if any of this is relevant in Silicon Valley. So we found the Founder Institute, which is an early stage incubator, and we basically walked in there with this notebook and some napkin sketches of robots, and this amazing team that we had built with Sextant. That's what we had starting Founder Institute. And for, I think it was like $1,800, they let us into the program, gave us free food. So within 3 months, I had been quit my job / got fired. We incorporated, leaving Founder Institute, we immediately raised 185K, and we just closed our angel round back in June. Filed 5 patents, 2 trademarks, and our prototype, our first prototype, is just Raspberry Pi hardware shoved into a tube that we 3D printed over my, right here in my living room. And basically, you can see the quadcopter concept here. So we started with Raspberry Pi just to prove the concept, and from there we went to the first custom electronics and BBs and JB Weld. This was the first time we had most of our own hardware, thanks to Dan Moyer, who's on this call designing it. Then from there, we got to thumb size, and this used a big stack of PCBs that connect together. This really started to get people excited. This is really what kind of led into our angel round coming together and closing. Mm-hmm. And finally, our latest design, Dan has us on a flex circuit, and basically the way it works is you just sort of fold it up and shove it in a tube, and you sort of have your electronic stack. So right before you close up a robot, it looks kind of like this. And so to get beyond here, in the short term, we can probably take the 5 boards you see here and go down to 4 or 3. But really, the reason you see us at this scale right now is we're trying to get to market cheap and fast. So that's off-the-shelf battery, off-the-shelf motors, off-the-shelf camera, and no ASIC. But we think if this becomes a hit, then the pill surgeon that follows, even at this scale, will start to advance the tech. And to go to rice grain size, yeah, that's some fancy ASICs, custom motors, custom batteries, wireless power. But those are all things that can be done in Silicon Valley. Or, I mean, you wouldn't tell anyone in Silicon Valley that would be impossible, right? So the key for us is just identifying what's a minimum viable product that we can build using the tools that we have, and with the help of from our first investors and our angel investors.
I have a question. Like, so I assume there's a programmable microchip in there. What platform is this running on?
All right, Dan, you're up.
Yeah, so so currently we've got an FPGA to handle interface to the camera and the video compression, and then we've got a little PIC microcontroller that's handling the sort of radio interface and driving the motors.
Gotcha. Very cool. What do you use for radio?
So we're using a Silicon Labs radio right now. We're probably going to transition to a different one because we haven't gotten the sort of data bandwidth that we were hoping to. So as a result, right now our video we've sort of like pared back our video to this black and white low resolution thing that sort of compensate for the for the failings of our radio link. We're actively working on fixing that for the next revision.
Is there any difficulty with like transmitting through the human body? If it's anything like underwater robotics, you can't really use radio.
Totally. Yeah. So it's not quite as bad as like, submarines that have like their, thousands of meters of antenna, and going at like super, super low, frequencies to transmit. But yeah, it is a challenge, right? So some things that we're doing to get around that, we took the frequency. So a lot of sort of off-the-shelf radios work at 2.4 gigahertz, the ISM band there. We're actually transmitting at another ISM band down at 915 megahertz, and that lower frequency helps us a little bit get around, trying to transmit through effectively, salt water in the human body.
Yeah.
And then obviously it has pretty big effects on sort of the geometry of our antenna. And then beyond that, it does just, there's only so much you can do because we're limited in the size of the thing, right? In general, antennas get better and better up to a point, the more volume you let them occupy, and we don't have that luxury. So yeah, so we're definitely getting hammered by the saltwater environment, absorbing everything, and detuning the antennas, and by our lack of room for like a nicely sized antenna. So those are all challenges. However, we seem to be able to make something work at least.
The fun part here to sort of tie that up is we're going to show you, live video on this thing, and it's like 48 by 48 pixels, a couple frames a second, grayscale. But with onboard image compression like JPEG coming on pretty soon, which is actually pretty hard to program into an FPGA. So Dan's been sort of sweating blood over that one. But we think we'll have that soon. That gives you maybe 10x. The next radio, we're looking at maybe 20x. Overall, about 200x more oomph in the next generation. So we're actually stoked to show you this guy, because this is like pure R&D that we're really proud to just include you on. We love our little baby. She's imperfect in every way, but it's real in every way. That's the cool thing, is that this thing is actually finally real, and that's been amazing.
Yeah, I got a lot of respect for people who get a physical product or prototype built. So kudos to you and your team. I'm wondering, speaking of test subjects and environments to test your radio frequency, is there any way we could see a demo today?
Well, you know what? It just so happens that we've got one of these lying around. If you'd be up for it, I'd love to kind of show you how this thing goes together. So
that would be amazing.
Basically, and you mentioned hardware, James. You're going to see come around in a view here. James Erd is like the third part of the triad of Endiotics. Get that beautiful mug in. James owns like between 40 and 60,000 pounds of machine tools with us in our warehouse in Oakland, and we like to make weird stuff. I got it. Oh, he just looks so good. Okay, so what I'm going to do is basically take this guy that's all soldered up. We do a lot of soldering under microscopes just because this stuff's pretty small. I'm going to put it together, and then we got a good signal here. So if you don't mind, do you mind if I share my screen?
Go for it.
Go ahead.
All right, so I'm going to go ahead and share this guy. And there we go. So when I put this together, hopefully we'll go live, and you should see some live video come through here. All right, there we go. So that's me. James, do you want to get in here?
Awesome.
So what we'll do now is slide this nose cone on, and yeah, that looks pretty good. Good signal. Radios look good. James, why don't you take that from me? All right, and then I'm gonna put this guy to sleep for a little bit here. Oh, I gotcha. So I'm just gonna sleep for a minute and 30 seconds. What James is doing right now is, and then yeah, we got our little, you can see on the screen I'm putting control inputs in. What James is doing is he's actually chucking the bot onto a little teeny lathe and using it to spin it slowly while he does a glue joint. And then he's going to do an ultraviolet cure. And basically that locks that bot in, and it should be able to pass through my GI tract without killing me. Typically, I take about 24 hours from swallowing one of these to finding it where you might expect it. And I got to tell you guys, like, in late October, of 2018, when I was like machining blanks and swallowing them and like gloving up and like digging into the toilet to find them, I was really thinking like, this is either like the most glorious backstory on like a Silicon Valley startup, or this is just where my life just started to unravel. Right. So, but the fun thing is just, if we can pull this off, we can help people, we can capture cancers earlier. And, it's like, I feel like this ought to exist. And so it's okay to get uncomfortable and weird sometimes.
Definitely.
I have
Yeah, what's
one
up?
question. So the robot looks very, very, very good. I mean, and I was wondering like how long does the battery last? Because you are doing so much processing. So
Don't
that's
worry about
why
that battery, James. So the question is battery life. So right now, battery life is kind of hilarious. I'm going to save a video here. Let me see here. Smoothing mode on, and we're going to go ahead and record. And let's just get us a little folder here. Let me see, new folder. Thanks for bearing with me, folks. So this would be Flux is what I come up with at the moment. There we go. There we go. Go in there, and we'll just call this file name 1. Okay, so
Well,
we're
it's not
recording
staged,
frames now.
Didn't even have a folder set up.
Awesome. So you're actually on a lathe right now. So the question is battery life. So right now, if I just go to full power, full throttle, battery life would probably be like a minute or 2. If I give pulses of power and just sort of be sparing with it, usually we can do maybe like 5 to 10 to 15 minutes. What's helping us is that doctors don't want to use these for very long. They want to get the job done in about 5 to 10 to 15 minutes. We're going to try to get battery life up to like 30 minutes, 45, an hour. But a great question. All right, so we're saving, smoothing's on. Let's do this. All right, and I'll just kind of put this radio into my shirt, and then we should start to kind of see stuff. So it takes maybe 10 seconds to work its way through your esophagus before you get into the stomach, and then you finally start to kind of see stuff and features. This is going to be really grainy and choppy, but we're kind of excited to sort of show you this, so bear with us.
Welcome to the Magic School Bus.
All right, so let's take control here. So you put in little commands. Looks like yaw. Let's yaw around. I saw some folds over there somewhere. There's definitely ew. Notice that, like, at the bottom of the stomach, you see the duodenum is kind of like this pinched off thing. One of the fun things about where we are right now with this tech is this thing sinks like a stone, right? And we're moving in the direction. Yeah, going back's kind of fun. We're moving in the direction of being able to float perfectly in volume, and sort of get like real elegant motion. Right now, this is just like crazy Mario Kart. But yeah, with 200 times more throughput on the camera and a little bit more buoyancy, we actually think we're doing something here. Like, you can see texture. If I'm a doctor, I would be able to sort of start to look for features and sort of areas of interest.
Yeah. I have a question. So your stomach is essentially right now filled with water, and the pillboard has a light on it, apparently, right?
Yeah.
So we're getting a pretty clear picture, right? It's pretty cool. And then other questions like, is there like a gyro on it? Like, do we know what the orientation right now? Or
Right.
Guesswork?
So at Rev 2, we try to make Dan's job pretty easy, and I'm just going to pile it around, and we'll see if we can see anything. Seeing some folds and some texture is kind of where we are right now, but we do expect very soon to be sort of duplicating the power of an endoscope here. So to answer your question, actually ask that question one more time.
I was asking, do you have like a gyro on it, or do you? Like, how do you orientate yourself, I guess?
Right. So we think we're going to move in the direction of having a gyro. So we always know orientation, and we can use radio triangulation to know location. And so the goal here is actually to be able to create real-time holograms glowing inside the patient that anyone with AR goggles would be able to see. So we're gonna have a ton of fun with this. The key was just getting to the point where we could actually swallow it and start to understand what we needed to improve. So believe it or not, this is some of the better imagery we've picked up. Like, anytime you get a high contrast image with some texture and folds, like, what's that white thing? I have no idea what that's like. That's my duodenum. That's my duodenum. So
awesome.
not the duodenum. Sorry, that is the pylorus. That is the pyloric sphincter. It's a valve at the base of your stomach that admits you into the small intestine, into the duodenum. Our interest with that is once you get through the duodenum, the bile duct dumps in, and we want to snake a little probe and have a look at the pancreas. So when we're just doing your endoscopy, we can check you for early stage pancreatic cancer. Maybe catch that 10 years earlier. And, you know, I mean, that took out Steve Jobs. It took out Ruth Bader Ginsburg. Like, it's hard to get this far into the body easily. And so for us, we think there's this tremendous opportunity to start affecting the lives of patients around the world. And we get to, yeah, that is definitely.
Look at that.
That's
so
wild.
Cool. That's crazy. So we're at the base of the stomach. All right, awesome. So we could do this all day, but here, let me go ahead. Dan, I'm just gonna leave this recording frames, and does anyone want to start asking questions or
yeah, we have a bunch of questions in the chat actually.
Yeah, so let me pop off a screen share here, and we'll have the onboard footage later if we want to tie that video on.
You could leave it on while you answer stuff.
Okay. So I can share screen, but please, I'm super glad to be able to just talk to people now. Yeah.
Les, do you want to take the questions from the chat or?
Oh, and then the other thing is we finally think we've got control over internet protocol pretty soon. So if any of you have Xbox controllers and you want to race around in my stomach, you know, let us know.
Oh my God, that sounds amazing. Sign me up. All right, I'm looking through the questions. So one of the first ones, let's see. What sets you apart from your competitors? I've seen articles in the at least one that crawls and takes a biopsy.
Yeah, those are awesome. So like the traditional old school competitors would be the passive pill cameras, which don't give you control live feed, like, you know, and then the endoscopes, the colonoscopes, where you shove it in, but you get full control. So we kind of understand how we differentiate from them. Let's get more fun here. So our closest competitors right now are based out of China, and they're called Ancon Technologies. And what they have done is awesome. They put a magnet inside of their pill camera, and then the patient sits in a big machine that can manipulate like very powerful magnetic fields. And so it's awesome because you can induce motion without having to put the tech on the robot. The cool thing for us though is like we think that we are going to kick ass in the stomach as like a first market here, like kind of what I'm showing you here. And the hope is that we will be a good competitor with Ancon without having to sell you a super expensive piece of capital equipment like that magnetic machine. And so our goal is to deploy this thing anywhere in the world, like even get the pill from the pharmacy and swallow it at home over a video call with your doctor even. Maybe in space, maybe on a battlefield or a third world country or something. But yeah, Ancon really validates our vision, and I guess we're happy to have a little bit of differentiation. But those are number one. Now you mentioned crawlers. We've explored that too, and honestly, anything that lets you move around in the body is cool. I wish I had a robot right now that could just push through my pylorus and just start cruising through small intestine. Right now, that's like a boss at the end of a video game level, right? We're scratching our head over, you know, what we do there. In the meantime, there's this awesome, exciting market and patient population of people with bleeding ulcers and cancerous lumps and polyps in their stomach. So it's like, our goal is to make the simplest, dumbest, first version of this that can just race to market, get revenue, and actually affect patient lives. And you know, if you look at the first Tesla Roadster, like the original, compared to like what's coming out or a Plaid Model S, like generation on generation, you know what happens. It gets super cool. So let's just start here and run with it.
Yeah, I'm excited. What's next? So we have some, that question was from Kevin. Everybody, Rachel says woot woot. Wow, pill shot swallow. Wow. Pretty epic.
There's a question about the frequencies and the error correction codes. I think you missed.
Oh yeah, one of the frequencies, so this is from Carl Frederick. One of the frequencies best for body of water of sound versus light, besides how much error correct codes, EEC. Yes. Besides the human body, wonder if there are any specialized mechanical systems where similar capability might be useful for diagnostics
Oh, dude.
or otherwise.
Well, first of all, how about just screwing around with the fish in your fish tank, right? like, come on, let's have fun with this. Like, people say you could swim it through industrial piping. Sure, absolutely. The concept of a quadcopter swimming robot, yeah, it's got applications other places. And then just the concept of of a remote control robot, or maybe even an autonomous robot. Dude, let's go to Mars. Let's put boots on the ground there. But like, yeah, there's no limit to what you can do with cool robots, in my opinion. To be honest, we want to build a giant Black Widow spider that can gallop at 75 miles an hour with 40 passengers on it. That's kind of another story.
Sounds like another Burning Man project. Carl also asked what type of cleaning envisioned between users, how to clean it.
Oh, yeah, right.
Reuse.
So welcome to the world of medical device, right? So all of the value that we just got out of that robot was transmitted imagery via video. So the value here is the diagnostic power it gives the doctor. Once the battery runs out, this thing basically has no value. If I wanted to make this reusable, then what we would save would be the $25 that went into building the robot, right? The problem is to make this reusable would turn that into like a $2,000 robot. And that's a conversation we can have anytime. Medical device, you know, you would imagine what this looks like when I go find it tomorrow, right? It's gonna look exactly like what you would think it looks like. It smells bad, it's packed full of stuff. If someone has like HIV, there's a ton of shedding of viruses in that debris, which sort of can get places. So for us, we're going for the single-use disposable thing. On the environmental side, I'm just excited because now I have access to like paper pulp packaging trays instead of the giant molded plastic sheeting from the past. So bottom line is, please hook us, hit us up anytime you want to have a talk about how to do this better. And we're going to be leaning into the hard questions for sure. We don't want to run away from it.
There's another question from Gian also about the propulsion mechanism.
Yeah, what's the question?
Basically asking what is the propulsion mechanism?
Simple. So right now it's just 42-cent cell phone vibrator motors that make your phone shake with a little propeller on it, and then a shaft seal that James created. Part of our warehouse burnt down, unrelated to us, a while back. We lost access to our machine shop for a while. So we lost the ability to work on the seal project. Then James just pulled this idea out of nowhere and that's actually central to one of our patents right now, is the way that we seal our rotating shafts without putting too much of a mechanical load on the seal. Because as you saw, we just ran that thing out of battery just now. And some of that juice was trying to overpower those seals. So it's a sealed electric motor with a propeller on it that can push and pull, and then 4 of those that gives you the ability to do differential thrust.
Speaking of thrust, so how, I think, where did the question go? It was about how much control do you have of the robot as it goes through the body? Because I guess liquids are kind of pushing it around. It has sort of natural course that it takes. How much can you steer where it's looking?
I can, I can direct you to some of our R&D in my sink or glasses of water. Basically, these things are like little Ferraris. They'll like zip around up the bowl. They'll spin in place. We can spin it along its axis. In fact, we've explored using that as a way to power a cutting tool. It's just spin the robot and put a tool out in the front of it. And so it's just like a quadcopter drone. If you ever seen like drone racing videos, you can do crazy stuff. Now, things we're pushing through right now, buoyancy, we'd like it to be a little better. That would let us rely less on the propulsion. We want everything to be better on it, but we're excited because we think that we're just on an iterative path to our MVP, and there's no crazy hurdles in the way.
So this is probably the last question. We have 5 minutes to kind of wrap up. Maybe one more. So a couple questions about ultrasonic. Have you ever considered using ultrasonic instead of radio? Makes triangulation much easier.
Oh, hell
Ultrasonics
yeah.
couple
Yeah.
the body very well. That's
So
from
James and I sort of barged our way into Stanford to watch this brilliant PhD student do her defense, Dr. Farah Memon, because she had created at Stanford a pill that does ultrasound as it passively goes through the body. And so we sort of crashed her defense and said, hey, you want to work with us? And like, let's put ultrasound on our pill. And her professors was like, you can't make swimming robots that work in the body. That's impossible. And we're like, well, I mean, all we had at the time was this guy. I can understand they might have felt that way. But anyways, Dr. Memon is now working for Butterfly Network, making this amazing ultrasound machine that's handheld, which we now own. And we use that at Endiotics all the time. But we want to do ultrasound from our platform. We think it would help us find things like cancerous lumps that are beyond the tissue wall that you can't see with our camera data. And we'd like to be maybe combining ultrasound vision with camera vision to provide the doctor with sort of like this upgraded way to look into the body. Bottom line is we want to do everything, and we feel really lucky that we have a place now that is like a good start. But if you're interested, you know, in doing crazy stuff, give us a call. And it honestly, we feel really good to be able to call out Dr. Memon as like a badass in the world of, you know, 21st century ultrasonics.
Yeah. One last question about flagella versus propellers.
Totally. So we've got like, we started brainstorming like, how do you get a robot to move through the body? And it was like contra-rotating corkscrew, flagella, tank treads, undulation, serpentine motion, like wire mesh shape memory alloy, piezoelectric, little oars to push you along like a millipede. I mean, we built and tested like a bunch of different versions of these things. And finally, the head of our advisory board, Dr. Benjamin Bonas, who's a ER doc, flight surgeon, badass dude, also may or may not be my older brother, who likes to do surgery on me in the kitchen table at Christmas. We basically said, he was like, dude, if you just drink a bunch of water, you can swim around kind of. And all of a sudden, things got really clear for us. It was like, there's a market in the stomach. Believe it or not, I've taken these guys up the other direction with a lot of water, and that's a whole story we could take offline. And that's plausible too. But we really kind of look at this from the perspective of patients and people that want to feel better and are scared about why their belly aches. And so it's like, if we can just have you go in your street clothes, drink some water, and we can help you, that's probably the product we'd prefer to create.
Yeah, makes sense. Well, I think we can wrap up. Torrey, Dan, thank you so much for joining us and doing a demo and sacrifice your body. But it's really, really cool. I think these kind of moonshots in healthcare, more people need to be taking them. And on that note, where should people go if they're interested in what you're up to?
Yeah, so I threw my contact info in there. So I'm on LinkedIn, pretty easy to find Torrey Smith on LinkedIn. Endiotics.com is our website. We're easy to find, and we are so proud to be able to just do this collaborative live Q&A, not with a polished finished product, but with actually, like, you're in our R&D lab, like, the 3D printer is like right over there, our little lathes right over there. We stole my brother's laser cutter, it's over here. Nice. So like, we love this concept of just being open and raw and collaborative. So if anyone on this call or watching later needs advice or mentoring, or you need to get introduced to an investor that we know, like, this is an open channel. Like, we want to be a part of this community and contribute to it, because we certainly feel like we're benefiting from it.
Cool. Well, thanks so much.
Thank you so much.
Thanks so much for joining us. If
Awesome.
you want to continue the conversation, I think, Torrey, you're in our Facebook group, co-conspirators, so we can pop a link in the chat if you're interested. and
So-
maybe we can do a little bit chatting back and forth afterwards.
What I'm excited about, you guys, is the democratization of circuit design is awesome, because when we do circuits, it means Dan does circuits, but I want to start doing circuits too. You know, I'm trying to speak his language. And what I'm really excited about the Flux project is just, for the first time, I'm seeing a circuit design program that's like, hey, wait a minute, that's accessible to me. I think I could actually start chewing on this. So I'm kind of excited, and I think I just might make like some cool light up sunglasses as my first project.
Yeah. And that was exactly the goal, right? We wanted to make it easier for people to work together on these things, you know? Like the future is not going to be built by a single person, you know? It's going to require teams. You know? Cross-functional teams.
I sat on the idea for Endiotics from 2014 to 2018, trying to do it all myself. That's 4 years that we could have started it back then. So to anyone on this call, it's okay to ask for help. It's okay to reach out to your collaborative community. And then if you need any kind of mentoring, whatever, like, this community is vibrant, strong, and motivated to help you start your company, right? So let's do this.
Appreciate that. Thank you so much. I think we'll wrap it up.
Guys.
Yeah.
Thanks everybody for joining us today. Happy
Thank
Friday.
you.
Thank you.